part 1 of this tutorial, we saw how N2KAnalyzer can be used to display information about a device and see the data that the device is transmitting. Now, in part 2 of this tutorial, you will see how to set up N2KAnalyzer and how to configure Maretron devices. You can set up N2KAnalyzer to meet specific needs or preferences that you have. All these options can be found under the Setup menu at the top of the screen, and we will now touch on some of these. Pressing Units allows you to change the units that are used to display the data in the messages. Press OK to close the Units dialog and save the new units you have chosen. Checking the Download Software Updates on Startup checkbox will cause N2KAnalyzer, each time it is started, to query the Maretron website for new versions of the program and also to check for new versions of device software. If you choose not to do this automatically, you can always check manually by clicking on Web, then Download Software Updates. The Listen Only checkbox needs special mention. Normally, when N2KAnalyzer starts up, it sends out queries to every device on the bus, asking each device to supply all the information it has. This means that N2KAnalyzer has disrupted the normal operation of the system by generating extra messages. In most cases, this is okay, but when you just want to monitor what is happening on the bus without generating extra messages, you check this box. The disadvantage of doing this is that a lot of important information will not be requested. When we save a boat file, we have the option of also saving the complete internal configuration of every Maretron device, such as calibration data. The Save Device Config in Boat Files checkbox controls that option, and we suggest that this be kept on. This extra data can help Maretron technical support look at your system if you ever have to send us a boat file. On the other hand, turning this option off can speed up the process of saving a boat file. Pressing Columns allows you to customize the columns displayed on the device list. We now move on to how to configure the devices. Instance numbers are very important on an NMEA 2000 network. Each device has its own device instance. When a PGN is received by a device, the device will associate the instance number with the data so that it knows which device the data is coming from. In some cases, where a single device has multiple channels of the same type, each channel has its own instance number called a data instance. For a system to work correctly, we need to configure the instance numbers and other parameters in a device. Open the Maretron.net boat file as you did in Part 1 to access the data used in the video. We will look at how to configure a device using N2KAnalyzer. Using the first TMP100 in the engine room as an example, click on the row in the device list to select this device, click on Configure at the top of the screen, and then click Configure Device. The dialog that appears will be customized for the type of device that you selected. You can see which device that is by looking at the title of the dialog. Note the tabs along the top of the dialog. The first is marked General and contains most of the parameters that you need to configure. The second is marked Advanced and contains the advanced parameters. The device instance is always found on the Advanced tab. The next tab is PGN Enable/Disable, which has a list of PGNs transmitted by the device. You can set how frequently these PGNs should be transmitted or if they should be switched off. The final tab is where you program the installation descriptions for each device. These are two fields that every NMEA 2000 device must have that can be set by the user or the installer. Click on the General tab. For the TMP100, you can enter a device label, and then for each of the 6 channels in the device, you can program the channel instance or data instance, the type or source of temperature that will be measured, and the label given to that temperature. On Maretron displays, this label can be displayed as the title of any control showing data from this channel. Any field that is white in the dialog can be changed. After you have made the changes to reflect how the TMP100 is to transmit the temperatures, press the Put Config to Device button, and the changes will be saved to the device. If you are concerned about a device losing the configuration that has been programmed into it, or you need to move the configuration to another device, the configuration can be saved to a file on your PC. Just press Save Config to File. We strongly suggest that you save all of your device configurations to disk using this method to create a system backup. Later, you can load this configuration from the saved file by pressing Load Config from File and put it back to the device or another similar device. Another way to configure the device instance is to select the device, press Configure at the top of the screen, and then press Device Instance. You will need to use this method to configure the instance numbers of devices like the TSM800C, TSM1330C, and MBB200C. Ensuring that all the different data channels on the network are associated with unique instance numbers is difficult. For example, it is important that no two temperature channels in the entire system have the same source and instance for temperature, or that no two tanks are reporting fuel levels from the same tank number. To help you, N2KAnalyzer has a powerful automatic analysis tool that will report on any system-wide instancing conflicts. Allow N2KAnalyzer to run for a couple of minutes to sort a full set of PGNs, and then press Analyze at the top of the screen, and then press Instancing. N2KAnalyzer will display a report of which PGNs have instancing conflicts. Here we have 6 such conflicts. Get more detail on the first conflict by clicking on the first row in the dialog. On the device list on the main screen behind the dialog, the 2 devices that are causing the conflict are highlighted. This tells us that the SSC200 and GPS200 are both transmitting PGN 127258 magnetic variation, and the device instance of both the SSC200 and the GPS200 are 0. To correct the problem, you will need to be connected to the live network. Working from a boat file will enable you to detect the conflicts, but you will need to be connected to the boat to change the instancing. Close the Instancing Analysis dialog by pressing on the X at the top right, and then select one of the devices with the conflict. Go to the Advanced tab and change the instance number away from 0. Press Put Config to Device to change the device instance on the device itself. Now we can run the Instancing Analysis tool again to see if we have chosen a value that was not used elsewhere. If it is fixed, we can move on to the next conflict. Highlight the fluid level conflict. This shows a conflict between the TLM150 and the FPM100. If we examine the configuration of the TLM100, we see that there is a tank number of 0 with a tank type of fuel. The tank number is another way of describing the data instance. If we look at the configuration of the FPM100, we can see that channel 0 is also configured to report a tank type of fuel with a tank number of 0. Change one of these instance numbers to avoid the conflict. If we change it to instance 1, then we will conflict with channel 2 of the FPM100. Changing it to 2 will conflict with the TLM200 for the day tank, so a better value will be 3. Now it's time to connect N2KAnalyzer to your own NMEA 2000 network and look at your devices. Your PC does not have an NMEA 2000 connection, so we need a bridge to connect between the PC and the NMEA 2000 bus. You can either use a Maretron USB 100 or a Maretron IPG 100 to make the connection. If you choose the USB 100, first install the USB 100 drivers from the CD supplied with the USB 100 device, and then connect the NMEA 2000 connection and the USB port to your PC using a USB cable with a Type B connector. Alternatively, you can use the IPG 100. In this case, connect the Ethernet port on the IPG 100 to your ship's router. You can either use a wireless connection between your PC and the router, or another Ethernet cable. You will need to establish a connection to the router from your PC to access the IPG 100. Now, start N2KAnalyzer. It will start looking for a gateway, and when it finds one, will ask you if you wish to connect to it. You can also find and select your gateway by pressing Setup and then Configure Gateway. This is really useful if you have multiple gateways on your system. The dialog will display a list of possible gateways. Select the gateway that you want to use and then press OK. Under the File menu item, there are also options to connect to the NMEA 2000 network, to disconnect from the NMEA 2000 network, and to refresh the device list. Pressing refresh will clear the device list and then send PGNs to query all the devices on the network. This can be a useful function if you suspect that a previously working device has stopped working or has been removed from the bus. As soon as a connection is established, N2KAnalyzer will start probing the network for devices and will populate the device list. Maretron has a complete range of tools to help plan, maintain, and fault find on NMEA 2000 networks. N2K Builder is a powerful, free, PC-based tool for designing and verifying the integrity of NMEA 2000 networks before installing a single cable. It will also produce a bill of materials for Maretron products to help your ordering process. N2K Meter is a diagnostic tool that plugs into the NMEA 2000 network to detect wiring errors and other network problems. N2KAnalyzer is a PC-based software tool that interacts with the devices on the bus and lets you perform an enormous variety of configuration, updating, and troubleshooting tasks. These three tools should be found in every NMEA 2000 installer's toolbox and on every vessel with an NMEA 2000 network. Thank you for watching this video. Please visit www.maretron.com to learn more.